All right, next I'd like to talk about supermassive black holes. So far the kinds of black holes we've been discussing are the stellar variety, i.e. they are black holes that formed from the death of stars that are maybe 20 to 30 times the mass of our sun that eventually collapse down to become stellar-sized black holes. But there are other types of black holes too. They're the type that are called supermassive black holes. And so these are thought to exist in the centers of most galaxies. Remember we said before that the radius of the event horizon of a black hole is about 3 kilometers for every solar mass. And so what we've discovered, if we look at our own galaxy, we have a galactic nucleus and we have the spiral arms. If you look at it from a side view, it just looks like a disk. Now in the center of our Milky Way galaxy, we have very strong evidence to support the idea that there's a black hole in the center that has about 3 million solar masses at the center of our galaxy. And as a matter of fact, we're so sure of this that we gave the guy who discovered it $1 million prize. And so they don't give money away if there's some chance that this is wrong. They're not going to give away $1 million. So this is a pretty good indication of the fact that this has stood up to all of the different tests that have been performed on it. And so this is 3 million solar masses. Okay. And so if we go back here and we see that the radius is about 3 kilometers for every solar masses, this means that the radius of this event horizon would be about 3 million kilometers. That'd be the size of this black hole in the center of our galaxy. Well, the distance from the Earth to the Sun is 150 million kilometers. Okay, so that means that this is only something like 1/50th the distance from the Earth to the Sun. So it's not that big. It's not taking up a huge amount of space in the center. And so what was determined then is that these are the orbits of stars that are moving in toward the black hole. This is what this guy did that won the $1 million, is he traced the orbits of these stars, and essentially they came in like this, moving pretty fast, and almost turned on a dime near the galactic-sized black hole. And so from our best evidence that we have knowing how the laws of gravity works, that's the only thing it could be, is a black hole that is creating this kind of a gravitational disturbance in the center of the galaxy, such that all of these different paths of these stars, and there are many others too that I haven't shown you here, essentially could turn that quickly in the vicinity of the black hole. And so we wondered then, well, how many other stars have black holes like our own? And so we started looking out in the nighttime sky, and we discovered these really radical-looking objects called quasars. These are quasi-stellar objects that are mostly found at great distances away from our Milky Way galaxy. And so these, we think, are galaxies in an early stage of development. And they have massive, supermassive black holes at their centers. So the idea then is that this might be 1 billion times the mass of our sun. Now, by the way, we don't know exactly how you get black holes forming in the early universe that are that big already. This is one of the biggest mysteries in science right now, in astronomy in particular, is how do black holes get that big when the galaxies were first forming? Only 1 billion years after the Big Bang. You would think there weren't enough time to coalesce smaller black holes together to make a black hole that's 1 billion times the mass of our sun. There's just not enough time. And yet we observe these things here. And so in this quasar then, we have what we think is a supermassive black hole with maybe 1 billion times the mass of our sun. And then material is falling inward toward this black hole along what's called the accretion disk. In a spiral pattern. And some of that material goes into the event horizon, but black holes are kind of sloppy eaters. Only about 1/3 of the material falls in, and about 2/3 is spit out in these gigantic jets. Okay, and so this is how you can resolve that problem of, well, how does a black hole make these jets if nothing can escape from the event horizon of a black hole? And so you have giant magnetic fields that are produced by the spiraling particles. And about 2/3 of the matter is ejected outward, essentially is accelerated along these magnetic field lines. So they're ejected along these magnetic field lines in the regions of the poles of these, the north and the south magnetic pole of this rapidly spinning object. And so this creates the huge jets that we see. And so that's what quasars are known for. These are very bright objects. These quasars are very bright. And might be putting out thousands of times or more, maybe even millions of times, the energy output of our galaxy. So what we think these quasars are black hole power generators that are generated by supermassive black holes that are in the center. And when these galaxies are in an early stage of development, there's a lot of material around that can fall inward toward the galactic-sized black hole. and can create these incredible cosmic jets. Okay? And so this kind of an energy generating mechanism is thought to be about 42% efficient. And so for a natural process, that's way better than, for example, an internal combustion engine or the efficiency of the way that our bodies work. Nowhere near 42%. And so this kind of a process is quite amazing in many respects. It's a natural phenomena. And we also think that most really big galaxies have black holes at their center. One of the things that helped us to come to this realization is that in calibrating these quasars, if we just look up at the data projector again, we see these objects that are very, very bright. And so we go, well, let's try to find a galaxy that doesn't have this kind of effect, just for calibration purposes. And so naturally, what we tended to want to look for is a galaxy that's nearby that we thought wouldn't have a black hole. And so there it is, our neighboring Andromeda galaxy. And so you go, okay, well, we know this one doesn't have a black hole. And we didn't know that we had a black hole in our Milky Way galaxy at the same time. And so they started doing measurements, and they found that the stars were moving in really close to the galactic nucleus of this Andromeda galaxy, and it was estimated that Andromeda galaxy has a black hole at its center that's about 1 billion times the mass of the sun. And so this is when we came to realize that it's not just these unusual quasars that have these enormous black holes at their center, but rather most, if not all galaxies. Probably wouldn't want to say all galaxies have them, because even if they naturally form at the center, it's possible that a collision between galaxies could throw a black hole out and have it go in some arbitrary direction. But I think it's fairly safe to say that most very large galaxies have supermassive black holes at their center. And we're not exactly sure yet how those black holes got so big so early in the universe.